Hi, in this video, we're going to be talking about types of reactions, and specifically, we're going to talk about combustion type of reactions. Combustion reactions are usually my favorite type of reactions because these ones are the ones that are fun to show in class as demos and things like that. But basically, combustion is anything that is basically burning is really what it is, okay? So combustion typically means it burns. So a lot of times, combustion's really fun to watch or to see. So in a combustion reaction, what's really happening is there's a really important key component, and that is oxygen. So oxygen is going to combine with a substance. Oxygen is required for things to burn because it feeds the overall flame or whatever it is. But that's because it's supplied from the air. So usually we have an excess, like a ton of oxygen in the air, and that just will feed in to continue to burn, right? But that's a really important reactant that you have to have. And what happens is when it combines or burns, it's going to release energy in the form of heat and light as it makes new products. So if you see oxygen as a reactant, then you're going to call that a combustion reaction. There are synthesis reactions that can also be classified as combustion reaction. For example, the one that we did in class and you guys did in a lab was when we took magnesium, right? And we burned the magnesium with oxygen, right? So that burning of magnesium was actually a synthesis reaction, but at the same time combustion because we were burning that metal. Not all metals will burn and react with oxygen. Some will also be considered technically combustion, even though they're not burning. We typically would be like iron will oxidize over time, but we would typically call that just oxidation or a synthesis reaction. But you wouldn't know that. So if you see oxygen, you're just going to call it a combustion reaction. But either way, in these kind of reactions, synthesis and combustion would both be correct terms. So a generic equation for synthesis combustion is basically an element plus oxygen, right? And when you make your product, it's going to be that element oxide for whatever that ionic compound is. So you would actually have to so that's an ionic compound there. And so you would actually have to cross your charges on that to write the formula. And we'll do a demo like that in class, so you'll be able to get that. The hydrocarbon combustion reactions are also really cool. We see this all the time. Just lighting your Bunsen burner is a hydrocarbon combustion. So hydrocarbon is exactly what it sounds like. It's a compound that is made up of hydrogens and carbons. So CXHY. The X and the Y mean it can be whatever amount it is. We can add other things like oxygen on the end or hydroxides, or there's other things, but your main component is carbons and hydrogens, and we're combusting those. So that means we're reacting it with oxygen. Okay, so hydrocarbons contain those elements, hydrogen and carbon, in different ratios. These are typically what we would think of as our fossil fuels. So think like gasoline is octane, right? We've got methane gas, so that's what comes out of the gas jets in class. There's propane gas, which is what you would have in your propane tanks at home, and maybe your gas grill, or even like an electric heater outside, or not electric, a gas heater outside. But any of those, butane is like in a butane lighter. Those are all going to be hydrocarbons. So anything that's a fuel is typically a hydrocarbon, is what that would be. And you can look up those formulas online and see there's tons of different formulas for those fuels. But they're all going to have that main carbon-hydrogen format. So the combustion of a hydrocarbon is really easy because it always makes the same two products. So anytime I take the hydrocarbon and I add it to water, right, I'm always going to make carbon dioxide and water. Sorry, I add it to oxygen, not water. I always make carbon dioxide and water. So we're rearranging, and we're basically taking the carbons and the oxygens, and we're combining them with the hydrogens and the oxygen. And so we're making that compound. So any type of hydrocarbon you have, when you have it with oxygen, will always make CO2 and H2O. There is no exception to this, so this is a memorization, like very, very easy. So carbon dioxide gas, water vapor, sometimes they'll make water liquid. But a lot of times the heat makes it water vapor instead. So we're going to do a reaction in class. Pretend I did not just randomly draw that. We're going to do a reaction in class with this where you'll get some more practice on it. But here's kind of showing you what's happening. So this is showing you an example of propane, right? So we got propane gas is C3H8, and it's got oxygen gas. So see that oxygen has to be a reactant, always to be combustion. I can make oxygen as a product, but that's not combustion, okay? And again, that hydrocarbon and water making CO2 and H2O, and then we're using coefficients to balance it. So we're taking those atoms, breaking them apart, and then reforming them in a different way. And the biggest thing, which makes it most beneficial, is that heat and light. That's why we like those burning of the fossil fuels and whatnot. Okay, so let's look at a couple examples. So we've got hexane. So hexane is C6H14. That's hydrocarbon. So C6H14, I see that, I'm like, oh, hydrocarbon burns with oxygen or ignited, right? So that means my products are always the same. So anytime I take this, my carbon gets with the oxygen, it makes CO2. My hydrogen gets with some oxygen, it makes water. And then we want to balance it. So sometimes the balancing on these can be a little bit tricky. So I'm going to do it off to the side over here. So I've got carbon, and I've got hydrogen, and I've got oxygen. On my left-hand side, I've got 6 carbons, 14 hydrogens, and 2 oxygens. Now, one of the things you want to do is balance the oxygen last. Do your carbons and hydrogens first. The oxygen, you can make whatever you need it to be. On the right-hand side, I've got 1 carbon, I've got 2 hydrogens, and I've got 3 oxygens. We'll worry about our oxygens last, okay? In the hydrocarbon combustion, it's the easiest. Fix your carbons first. We're going to put a 6 here. That's going to give me 6 carbons. It's also going to give me 12 plus 1, which becomes 13 oxygens, okay? Then we're going to balance our hydrogens. So I have 2. I'm going to put a 7 here. So when I put that 7 there, it's going to give me 14, okay? So now I'm going to add these up. I have 12 plus 7, and help me out. 12 plus 7 is 19. Thank you. So we're going to adjust this, 19. All right. Hopefully I did that correctly. Yes. All right. So then we want to balance our oxygen. So what can I make this oxygen? 2 times what will give me 19? Well, in this case, I would look at it and be like, okay, so 2 times, what would that be? 2 times, so it'd be 9.5, right? Times 9.5. Everybody okay? Now, this is kind of weird because what can we not have? We can't have half of an oxygen molecule, right? So what we would do instead on that, and double check me, yeah, 18 would be, that did that right. Okay, I keep looking at it thinking I did it wrong. So when we look at that 9.5, right, we're going to look at it and think, okay, well, we can fix this though. And so what we would do to fix the coefficients is we would change everything all the way through. So remember, if I change 1, I got to change everything. So we're going to go back in here and I'm going to do it in green. I'm going to double everything because anything 0.5, if I double it, it'll make it a whole number. So 2, 9.5 is going to become 19. Everybody okay? So 9.5 times 2. This will become, the 6 will become 12. The 7 will become 14. Okay, so then if we go back, we should be able to check. We wouldn't be able to reduce that. But let's go back and check. So I've got 2 times 6. That's going to be 12. So I'm going to redo this. I'll do it down here. Carbons, hydrogens, oxygens. So I've got 12 carbons. I've got 2 times 14 is 28 hydrogens. And then I've got 19 times 2, which is going to be 38. Right? 38? Yes. So 38 oxygens. And then on my right-hand side, I'm going to have 12 carbons. And I'm going to look at my hydrogens. I'm going to have 2 times 14 is 28. And then we're going to check our oxygens. 2 times 12 is 24. Plus the ones in the water, that's going to be 14. So when I add that up, that's 38. So this works out. Okay? So we just want to double check it. But that's the easiest way. When you end up with a half, you multiply through everything. On letter B, switch back, You've got copper metal burned in the presence of oxygen. So copper is a single element burned with oxygen, so O2, and it makes. So in this scenario, usually we would tell you that it was like copper, let's say copper 1, right, oxygen, metal or whatever. It's not the ion, but it's telling us which ion we would make. So when we put those two together, right, because that's going to happen, this is a synthesis combustion, we would make copper, and copper is +1 if it's a Roman numeral 1, and then oxygen is -2, so that's going to be Cu2O. So we want to make sure we balance it. So I'm going to balance it. I don't need to write this one out for it. I feel like I'm pretty good on this one. I'm going to double my Cu2O so I can get the right number of oxygens, and then I just need to put a 4 in front of my copper. There would be my answer. All right. So combustion reactions are not that much trickier. The balancing is a little bit harder. But the hydrocarbon combustions, just straight memorization, that's CO2 and water. And then remember that the synthesis combustions are really just a synthesis reaction. All right, so if you have any questions, please bring those with you to class, and we can go over them. But we're going to do some demos and do some more practice as well.